Alright, yes, good evening everybody. My name is Jarmo Suomista. I work in the Helsinki 3D Plus project. And so we have such a fine company here now. So many sides of virtual reality, 3D modeling, city planning, game, developing everything. Fine, extremely fine. So I'll give this presentation in English. There are many reasons. So I speak slowly in English. I speak less in English. I use very simple words in English. So you can also, during this presentation, you can ask questions exceptionally, because this is not such a solid presentation, because this is informal situation. But we don't discuss the things during this presentation, so I hope that single questions you can of course ask in Finnish, and I maybe answer in Finnish. It's all right, of course. But let's do it like this. All right. So we have in Helsinki, and we have new generation city models, and we are very proud of them, and we are very happy to deliver them as open data, and we of course want to get benefits from them. Yes, we have a team of 2 people. So Kari Kaisla, my colleague here, he knows much more about rocket science than me, but something me also. Well, Kari has modeled city over 30 years, from the year 1985. I think Kimmo is also a very veteran of this. He has been in the City of Helsinki also from the same time. So much more, over 30 years of experience working in 3D. I have only a little bit more than 20 years. But together we have much more than 50 years experience. And so we have a coordinator. He's now doing his thesis work about city modeling. He's not working now, but he's coming back to our project, and he has worked for us last year. And so with these 2.5 people, we have done this project. We have 3D project, and so this is the 3rd year now yet. But let's see what happens. Probably we get more time and so on. Okay, let's go. Okay, and then why 3D? People ask, why 3D? Well, you have fine maps, you have GIS in 2D, and 3D it's for the movies and animation movies and 3D printing and for computer games, and we have seen 3D, but why are you doing the city 3D? Let's see. Yes, this is city planning. Well, this is city planning. So this is a detailed plan. And if I ask you know much about city planning and what's the quality of urban spaces, can you explain a little bit about that? Well, something yes. Well, generally the visualization is at least in this level, in 2D. So we have black squares there and things there, and the Roman numbers, if you understand them, you see they are rather big in Finnish context. And so you can, if something says something green and black, and you can guess that, well, this must be something about high-rise building. When the architect is doing the semantic IFC BIM models, it looks like this. And from these models, of course, you can do analysis then. You see the urban spaces. You can calculate and analyze the shadows there, maybe something about the wind. But it's a limited space there. But in the next picture, we have put it in that development project model in our new mesh model. And so you see the context there. And if you go abroad and tell what's happening in Helsinki, how are we building new city in Helsinki, this tells a lot more than those pictures. So it's about the scale we are looking at the things, and how precise they are, and what are we doing there. And if we put together, so this is the Kalasatama project there, you see the Kruunusillat there, so there's the Kruunuvuoren Ranta there. So new things in the existing context, and you understand the change of the city, the scale of the change, and from here you can do much more wind analysis, more sophisticated environmental analysis, and so that's why 3D. Okay. And in our project, so our goals are, we are doing 3D platform for various purposes, for processes, for developing projects, and also, well, city information model is now understood as part of a smart city operating system. So you can build so much on city information model with database, with semantic models, and so. Yes, common understanding of new developments, so discussing with the residents, and so that's quite clear. And then the analysis to the decision makers. So it's not any more the guess that the wind is like this, the noise is like this. We can plan these things because we can simulate those things when we are planning the new city, new areas, new developments. So it's not afterwards calculating, so it's in the limits, but we can plan them how much, what to do with those things. Okay, and then the environmental objectives, so carbon-free, carbon-neutral city, and so in Germany, where the city information model is mostly from and the most developed, they are doing serious working in universities, and so for carbon-neutral cities and greenhouse gas emissions and so. So city information model is very good and practical tool for that, and also Helsinki has some goals for that, to be carbon neutral for 2050. So, and then the open data, of course. We are here for for open data. And so, yes. And so in big picture, what are we doing with this new kind of city models? And well, this is the answer. Yes. Yes, we must understand the real world and the virtual world. It's one thing, it's the same thing in different sizes. So everything is now first designed and analyzed and simulated digitally and then built in the real world. And so we must have such intelligent platforms to do that we can really combine these things. First we combine these data and the geometrical models and semantic things, so we get intelligent models, so we add them, we integrate them to the processes, and so we can do things better, analyze better, doing better plans, maybe faster, avoid mistakes, and so. So open innovation in web, so we can get more and more, we get crowdsourcing, we get better results then, and so of course it has an impact of socio-economic ecosystem. So for example, for these things, if we think about Berlin is one of the most advanced users of city information models. They have it's Berlin Commercial or Industrial Atlas. So if you want to have a company in Berlin, you can check in 3D model, city information model, where are the same kind of companies located in Berlin, where are the free spaces for such companies, what kind of people are living there, where can you find your apartment, it's all in the same portal. So it has a huge impact for the startup company in the city. You get all those information in half an hour, except meeting a company information people, let's see, and phone this and this and this. So it's reality now. When I saw this first time in 2011, I think that, yes, let's see, so this is the future. But it's not anymore, so in 5, 6 years. Okay. Yes, 3D data, it has a great potential, yes. Yes, in US they have calculated something like that, so it's big numbers, and so, and of course you can calculate it, and this is so and so useful, and but well, where's the money? But it's under the line. Can you show the money what's to save them, and how do you get them? That's a trick to do. Nowadays, you can make city models, yes, you can have fancy models, and so, but to get the benefits there, get the use cases there, that's another thing. So it's extremely difficult even nowadays. So it's not like this. And that's why we are working very hard also in our project to get good use cases, to show the benefits to the decision makers, and so to get the continuity to our work. Okay. Yes, a little bit history then. So this is a picture from 1985 or 86. I don't know, has Kari done this or made by Kim or so, but this is the print from that era. So, and I think it's very beautiful. So it's like an art. So a little bit about the printer and how the color has dropped from the print and everything. But nevertheless, it looks very graphical and very nice. So it's okay. And so, and then this is 1999 from city planning. We have been done. We make a simulator for Kamppi-Töölönlahti detail plan. So it was a real-time simulator, game engine, and something for computers calculating there. And at that time it was really expensive and took so much time. But these are really pictures from that era. And so they are so long ago that people don't even remember that time. So hardly anybody of you have seen this in year 2000 when it was shown in an exhibition. But in that time people thought that it's a movie from Helsinki. And there's no, it's not a movie. You have a space mouse and you can drive there. And of course you have all drive space mouse. It's so easy to drive there. And there are some funny things that old ladies to come to city planning exhibition and said, yes, you can drive, you can use the computer. Yeah, it's worse. And so it was something so strange at that time. And even though it is now maybe something, but of course we have more sophisticated equipment now. Okay? And then we have the master plan simulation and modeling and so, and next one of course Pasila at that time. Very many plans and simulators we done in 2003 and so. So long work in Helsinki with that, and in the world scale too. So 1985, it's so early. I know no other cities like that. When we went to Rotterdam and we thought that yes, we began that 3D modeling there. Yes, really impressive that they began at year 2000. So it's something. So that's the background for now for the new city model. So it's not like this. So you must have the experience and know what are you doing. So you can just jump into the brain and do fine models. Yes, and the challenge is so yes, more than visual wow. It's okay to have visual wow, but the analysis and in city planning and developing the city in smart city, it's not the only the frames of the cities. It's much more, and so yes, and of course if the model is standardized, so you have the same model as the other cities in Europe. So we are the first city in Nordic countries to have city GMO model for the whole city. But in Central Europe, in Germany, in Netherlands, in Austria, they have a lot of city information models. And so networking with those cities, we have exactly the same kind of models. We can change experience, we can change applications, and so. It's very useful and it's power. And we are using open standards. So it's not closed commercial standard. It's open. So universities, different kinds of research institutes, cities, they all work with the same and can share them. There's a lot of open source applications there. So it's very different thing from that you have closed commercial system, one company doing, and you can do only that from the company. You can now change the data model there, you can do the addings there, and do what you want with that model. So. And of course the database is open source and so. And if you think we have done that in CityGML now, compare that to that we have used closed systems, commercial databases, and so we have saved taxpayers' money, I think more than 1 million euros. So it's quite a lot. And we have the same results. And more. Okay. Yes, let's go. Yes, and this is a standard. So city models are city GML, city information models, and there's IFC. BIM is for building, and infrastructure in Finland is improvement. We don't go deeper in that. Those you can read. And where we have city information, city GML standard models, mostly in Europe. There's Helsinki also. These are lands. They are not cities. They are lands. These pins there. And this the Inspire area is the red one, EU Inspire area. So mostly Europe, and then something in the US, Singapore, then in China something, in Australia something. But this is 5 years old, more than 5 years old. There are now more countries there. But I think Singapore is very significant because it shows the way the whole Asia, so it's very interesting. Okay, let's go. And this is our project in a big picture. So what we have done, we have laser scanned the whole city. We have had 50,000 oblique photos. So our raw data from those, it's 11 terabytes, so 11,000 gigabytes. It's the raw data for making these models. So we have cities GIS databases, we have the maps there, and we have the registers there that we can map the data to our information model. In the future, more and more IFC BIM models are used to make the model. So why to measure, why to laser scan the buildings if we have ready models for them, for the building inspection. So we have also the interiors there, and so laser scanning is very useful for other purposes, and it's not certainly not unnecessary for that. And of course, new geodata from cars, from mobile phones, and that's big data to see what's happening in the city model and get those data. And this is what we have done. We have done the reality mesh model only from oblique images, and then we have the city information model, the intelligent model with database, city GML model. These are different production lines, so different. First, when we started the project, we started to do this, only this, but then we realized that we have such 50,000 excellent photos from Helsinki. Why not do reality mesh model also, because the technology was available for us at that time. So we made it, and it was incredibly cheap to make it, and it's also useful. And as we think now, they are not against each other. It's very good to have both of these. So if you like to have realistic models for visualization from the flight, from a little bit above ground, it's very useful to have this. And if you do analyses, you have enriched the data, and you want to use the database, yes, let's do that. And yes, and how we get benefits there, so we have the services, we have by the portfolio, we are building new work practices, open data. We hope innovations in every level of this. Yes, let's go. First. Yes, this is in Finnish, this is some about collecting the raw data and how to do it. So, some figures for that. So the laser scanning was done from airplanes. I think the height for the flight was about 500 meters. And so the density was 20 points per square meter. So 20 echoes from the laser for every square meter. So we have it gets the cars and trees and even people and so everything. And you can different echo there, and you can classify them. And this is the oblique photos. So it was first time, I think, in Finland to use in such a large scale that special cameras that they take 5 pictures at one time. So it takes one like this, and then in 45 degrees angles like this, 5 at one time. Why is that? So we get also the oblique photos, and we get textures for the facades for the buildings, because it takes like this and there's like that. If we get only this, we get very limited pictures from that. So let's go for the top. And so then automated processes for making that. So City GML about 60-70 processes automatic processing that. So we have in Helsinki we have the little sheds included. We have about 80,000 buildings. Not so much, 80,000 buildings, and one person with that program made the geometrical semantic modeling. It took about 2 months, a little bit more than 8 weeks. So not so much. One person, 80,000 buildings, well, like that. So this new generation city models are a result of very broad technological and using advanced technology in a very broad way. So everything. So it's the laser scanning. It's the oblique photos. So it's the programs using that. It's the modeling programs. It's the capacity of computers. Everything. And you put these together so you can make these at a very reasonable price. Yes, let's go. And this is a little bit of the technology, how we do the semantic modeling. So we have the laser scanning, we have the building footprints, and we raise the footprints to the cutting point of the roof point cloud. And then the software is trying what kind of roof there is. It's trying to make the roof and calculating the points there and guessing that it's like this and this and this. And so we get, at the result, we get something like this, right shape of roofs. And this is semantic modeling, so the roof knows that they are roofs, this knows that I'm a wall, and so. And they are watertight solids, very good geometry, very beautiful geometrical, yes. Let's go further. Yes, and this is the semantic, spatio-semantic coherence, what's very important in semantic modeling. So if you have a building there, we have the in the data model we have the geometrical model that shows that what part belongs to what part and what is the whole thing. Well, it's a building there and so. And we have the geometrical structure here and we have the semantic structure here. And the semantic structure must be exactly the same as the geometrical model. And it is explaining what is this. So polygon here, this is a roof surface, it's a roof. So the computer knows like this. And this is very important if you want to ask, for example, from how many windows do we have sea view in this area? You have that, and yes, you can ask, and it tells yes, there's 5,500, yes. But without the semantic, spatio-semantic context, we can't ask. It's dumb geometrical thing then. So that's the point. Maybe we can use it for more sophisticated ways. But for example, like that. Okay. And this is a picture of in the first video you saw the mesh model, and this is a picture from the city information model. So this is semantic data, textured semantic data, and I think we have next a small video from the semantic data. So this is without the textures, so that you can see the data. So I think this is very beautiful data. I like this video very much because the data is so beautiful. It's so valid. It's all semantic without mistakes, and so it's very useful. And so, and we have done this. They are all new geometrical things, nothing from the old modelings, because it's very hard to do it better if you do it at first time wrong. So you must do the whole process right, and so you get the data like this. Okay, and then how are the mesh models made? So 50,000 oblique photos like this, and so it has nothing to do with the laser scanning. It's only photogrammetry from the aerial photograph. So what is the program doing? It's calculating points from different photos. It recognizes this point and calculates in different angles and gets the position of the points. This angle there, and I think it's 100 of millions of points for Helsinki, and so it makes the mesh there and gets the texture there. So this mesh model was calculated. I think there was 8 very powerful computers And I think it took about 2 months to calculate this, 2 months. And so we get this. It's only photos. Of course we have such ground control points that this is in coordinates. So the accuracy of this model is it's about 20 centimeters. You can measure there in 20 centimeters accuracy. How high is this? What's the difference about those towers? How big is this building? Yes. And you can calculate the volumes and those. So this is also open data. Not all city, but it's coming as soon as we get a little bit more servers there. And so you can calculate the volumes and so use it in very many ways. Okay. Yes, and this is a video about, yes, once again, a little bit different. Yes, let's look at this. So as you see, even the cars are pretty objects there, but it's only a mesh, like a curtain over the whole city.
This is summertime
15, yes. So we are now planning that we hope that we get the distance and that we get the new oblique photos this coming summer. So we get the new models. So that's because Helsinki is changing so fast, we are building so much, and this is, well, the whole thing is this is under 100,000 euros to get the model like this over Helsinki. So it is, I think, extremely cheap. So why not make it and get the documentation of Helsinki for 2 years and get up-to-date model. So now we can do it. So for us, it's not, and this is 99% automatic processes. Yes, let's see. And then about the benefits, yes. This something, so technology, yes, you can hype it, but where's the money, where are the benefits? Okay. There are many applications for 3D city models. Very many are open source, and you can do things, indoor navigation, emergency shadows, visibility, and so. And okay, let's go further. These are some examples from Germany. There's some, of course, the 3D analysis for different things, heating, winds, of course. And then there's noise analysis, there are flood simulations and how to protect city from the floods. And this is the urban blast simulation. This is very interesting because this is very German application because they find the bombs from Second World War still when they're building their cities. And there's always a problem. Yes, this is so big. And they used to, well, detonate them in the place, and it broke windows, and so what are they doing now? They have the information models that they broke down the bomb there and calculate what's the effect, and so that they protect the buildings there and evacuate the people there. So it's very, very handy there. Serious gain in carbon neutral cities and so. And yes, last week people always ask, how can you do this? Yes, there's some examples, but are there any more? Yes, there are more. In next picture, I think, this is more. This is something, so this is in Finnish, but of course, there are applications, what can you do with 3D city models and with city models, and these use cases. And when you cross those, you get about more than 800 dots here, and you get more than 800 use cases. Yes, let's do something like this, and so, and if this is something that we, yes, what's this dot? It's kaupunkitapahtuma. So it's city happenings, and there's, well, what's this? This is noise. What has city events, yes, do with the noise analysis? Yes, quite a lot, I think. You have a rock concert there, how is the noise, how loud can we play? Yes, so much. Yes, it can be very useful. I've never seen like this, but of course, why not? Maybe a web application there. So it's something, and for you, I even printed these because I think you can little bit look at them, just put them around. I think there are 50 of them, I hope there are enough there. Yes, this is something, and this is my own thinking, so there can be so much more, and this is a little bit generalized because I find them so more. And what are the blue ones there? The blue ones are something that we have done a little bit with our pilot portfolio. We have not done everything for that, no, not at least, but something. We have some kind of experience of those, but so much things to do. And what is your interest, what can you do best, and so. A lot of work to do for everybody. Okay. Yes, and what kind of projects we do. So if we have such a 4 square here, so we have easy projects, and so we have a little bit difficult that take too much work back. And so we have 4 cases there, so we have that's easy to do, small impact. So there's something to try. New technology, they're fun to do, so let's try this, and so it's less than 1 month. So easy, quite easy, but rather big impact, so we get very rapid use cases and rapid benefits there, analysis, simulations, some kind of videos there showing projects and visualizing something. So they are rather fast, but you get something. And then if you want to change the way of working, we are working with Helsinki Energy Atlas, we are working with new communication platforms, we are working to use the information models together with project managing, and so it takes at least 1 year to do it. But it has very big impact, so it's fine. Let's do that. But of course this small impact, lot to do, so it's wrong decision why to do this. It takes a lot of time, why? So maybe not this, if you don't have extremely much time and money and everything else. Yes, and if you're doing project, maybe you think something like that. And this is our part of portfolio. Small thing, many things. Let's go for. Let's see them. So yes, we have done something underground. Yes, next one. So we have done something with energy, with climate, big logo of City Lab. It's with Potsdam University. We definitely see this. This is very good. This is the most advanced analysis we have. We have the solar potential for every surface from the City of Helsinki buildings, from the 80,000 buildings, about 900,000 surfaces. And this is, I think this is the most advanced solar analysis in the world now. This is done with Technical University of Munich. They have done very good work there, and they have very fine applications for that. This is coming apart to be a part of a Helsinki Energy Atlas. And next one is, and this is something to do the using together the different kinds of data models. And next one. And this is the organic. This is the kind of this Unity engine based some kind of game to see how what kind of changes you expect to have in Oulunkylä if you have a new tram line there. And so yes, we see this also. And then a little bit about Berlin Hackathon. It was made in it took 6 weeks. And it was in summer 2015, and it was rather big event, and Berlin had then open data, and what kind of results there? Very quickly we see them. There are seven projects there. This is something, this was 3D printing, and I think the idea was that if you look at the 3D model, and so you get the connect to the 3D printing company, and you can choose there, and the next week you get the 3D print from that building or of that area to you in the post. So very, very simplified 3D printing. Yes, this is something to do with the flats, to sell the flats, so it automatically changes the 3D plan of the apartment to 2D to 3D and places it in the city model, so you can see the sun, how's the sun going there, what are the views there, so you don't have to go there because there are so many objects there to go. Yes, something like that. And then there was it was urban planning, so one decision wall to put things together. Next one, yes. And this was, yes, this is the greenhouse gas emissions. This has something to do with the climate kit. And this is something we have done in Helsinki too. We have used this one. This was Boston University project. Yes, next one. And this is, this was the smart map solution. And next one, this was some kind of added reality or adding pictures, old pictures to the objects and understanding the history, and so it puts together different sources of data. And the last one was, yes, this was virtual reality. This is something you understand, it was 2015 because this is useful now. But then it was such results we get there from Berlin. And then, yes, as a summary for the end, so what we should have, what we should do, good data is the key thing. If you have the city data and it's not valid, it's something like that, it's not accurate, so it's few meters for that direction of that. So what can you do with it? If you do city planning, you plan roads there. No, so good you can get. So, of course, we must have the standards that we can cooperate with other cities, of course, other countries, and Inspire is doing a good job in that. We must have the infrastructure to get the data, to deliver the data for you. So we must integrate the things to processes, to cities' internal processes, but of course to other processes too, to get the benefits. So it's not alone, and that's the hard part. Yes, and new workflows, you can develop new workflows if you have new tools, but it takes time. And you must understand the technology, and this is something we should have more, because this is not taught in universities, city information models yet, so you don't have specific classes for this. Yes, open data, and then you must think very creative of this. So there's no limits, and if you get the innovation, something very strange, it can be very useful. Something that nobody else has taught. All right. And this was that part, and I think Kari is now showing us a little bit about the services and the pilots. I think where we start. I think probably many of them have seen. This is, you can look the mesh. So this is the 3D Helsinki mesh, and you have the links. Every links you have the Help.e/3D. The links are all there from our website. So you can look this and see this. I think this is a little bit better than Apple has. And of course the thing is that you can download the data in different formats from HRI. That's the thing. So it's open data. You can do applications there, you can do visualizations there. You can take it to your computer, put it as a reference in your CAD program if you have such program that can handle that. There are more and more then. And you can start planning there. I have had messages from architectural companies that they're very happy that yes, we can use this. And it has saved a lot to them. That it's all benefits to us. Yes, it's there. Yes, okay. It's now whole city. At start we have some little bit, and I think it's right that during this spring there are more formats to come. Yeah, more and more formats to come, so you can get it. So this.
What are those formats?
Same.
Now there is OVT format, it's a mesh model, and maybe other visualization in our CAD format depends on what you need.
Let's see, so maybe a call, but yes.
Well, this is the city GMO, city model, information model for web forms. So there is that LOD2 buildings with textures and without textures. Take a little more. Well, and this is the information model. So you can ask some attribute data from buildings, for example. And then there is also a download portal here. You select the area of different individual buildings. For example, I can take that block there. Email address and tensor format. There are several CAD, GIS and 3D formats. You can get the link, download link about 1 minute, and then you can take it to your
And you can get the holes. Is it possible? Too much data?
Yes, by this portal, I think we make a data set files, but except to the Helsinki region area, for example, in shape or CDGM format.
So what's behind that service? There's an FME server that changes from the CMO database, and so the area is limited now, because if you take the whole city, it takes so at the start we want this. It has been since we opened it in the beginning of December. It worked from then, so it was very stable. And then, but the area is now limited, and we put it bigger and bigger, and we see how much it can take, and what's the demand of the data, and so. So we want that people have a positive experience of using this. But if you have that it doesn't work, I didn't get, you don't try it second time. So these limits.
You have street thing. Street thing.
Not yet. There is so there are coming.
Yes, the elements we have here now, so buildings and updating the buildings is very important. Once we get to the data model, we get the trees there. So Helsinki University is doing the analysis of the point clouds, and we get the streets and park trees there, and then the bridges. And these have to come at least this year. So there are several teams in the data model, land use and everything, but we add teams according to our resources and also the needs for the projects. So we are adding the elements there. So the analysis of the laser point clouds is done by university, but then we have the database there, and how to do the sales there, and the attribute data, we are doing that. Yes.
I want to market that we just released the data regarding parking slots and traffic signs regarding the southern Helsinki just last week, was it? But there are every single parking slots available, so that's very interesting data indeed. And there will be later during this spring the data regarding the real-time parking status. Is the parking slot available or not? That kind of data. That's very, very interesting indeed. So, yeah.
Yes, and this is the solar potential analysis. The
So it's city information model without textures because we have no use of textures in this case. And so every surface, so this is the Swedish theater, you know, this is Planat, and and every surface is calculated. So what we have direct solar energy, so we have the diffuse energy, and so we have the sky view factor. So how much do we see from the sky from that point? And yes, sun doesn't shine in Helsinki, as you know, but the energy sum of this part, this green part of the Swedish theater, is 400,000 kilowatt hours. So it's about 20 single houses energy. But it's not the electricity you get there, because the solar panels, what's the efficiency factor there? They get about 20% now. In laboratory they get 60%. But think, so 20, like that, you get something. And of course you can see there's also how you get the energy there. So in January, February, so much, but dramatic change in February and here. So it's like this. And where's the data? The sunshine data, it's from NASA. It's 22 years average sunshine in Helsinki and clouds also. And there are also walls there. And as you see from this grid, the calculating grid, it calculates also the shadows of other buildings and so. So this is very fine data. And so 80,000 buildings, every building, yes, every surface, yes. And this is something very interesting to combine it with some panel values there and calculate that then, because this is the most accurate, I think, in the whole world that you get from the solar panels. Yes, and this is coming to be a part of Helsinki Energy Atlas, I think during this year, I hope. It's not from the spring, I think it's in the fall. Yes, something like this. And then should we look at a little bit of the Okelikone, so it's the Unity machine. Okelikone, it was promised that it's open during December, but there was some discussions about Helsinki-owned rental buildings that were not shown in this, and so there was a little bit troubles in city planning about that, but they are now discussed the things, and so it's now opens in March, this Okelikone. But we can show the developing version of this. This was done with VSP. So, and the purpose, this is not connected to any real detailed plan project. There are only structural models of development of Oulunkylä area with the new Jokeri tram to come, and there's the train, so it's an obvious developing point. And there are three alternatives just to collect people's opinions and their goals and what they think about the change of Oulunkylä. And so, and from those things, then city planning is doing synthesis and showing alternatives of the real plan, and so. So this is only to communicate with the people, and so this is not so serious. But what we wanted to create a new kind of tool for this. So and it's not that people can design something, because designing cities is so difficult that you can do it with the web browser. There's alternatives. There's something that doing in city planning. Something's done in the internal competition, and I think there's something residential groups in some alternatives. And so there are three things. And yes, you click one alternative, so we are in the yellow, and if you click that, you get it bigger, and you see the bigger picture there. So you see three kinds of models. There's unity models there's mesh models, and there are buildings there of the city information model, simplified buildings there. And so working in web browser, WebGL technology. And then you have the viewpoints there, and you can drive there and look at the environment there and rather new building possibilities there and building potential there. There's tram trains going there, and I think the March version that is published, there are people going there and so. And for every point of you can write your opinion of yes, this is this and this is this. Yeah.
Is it possible that one person tells 100 of opinions as a different person? Or is that sort of regulated, because that was the problem with the general plan interaction, that if you are very active digital person, you can make an impact which is not at all common opinion, but it's one person or opinion processing group's version.
Yes. Sorry for the tram, but I think only was telling that if one person tells his opinion in a different way for 100 times, and so we think that that's very important because 100 people. And I think this is not such democracy. That's how many opinions you have. It's about thinking how good the opinions are, how smart they are, how can we work that. So if you have thousands very lousy and miserable opinions or goals or something, and why to do it? But no. And that's why, of course, good city planners understand what to do, and so. But of course, you can tell that there was 100 of these, but that's why this is not working.
But that was used like this.
Yeah.
There were
Certainly.
thousands of opinions
Yes.
to do this.
Yes, and
it can be contributed by one person.
Yes, I understand, and certainly something like that is happening also here. Yeah.
Of course it's happening.
Yeah. But it's yes. Well, I think it's a question about, do you have to register it and give your information, give an opinion, or is it open? And this point we think is open because this is such an experimental thing. Because we get more, and so it's very simple to use this, very simple to give an opinion, and so.
Anyway, I don't think it's a problem with the use of the information.
Yeah. Yeah, they go for a database, and so we have all them together connected to the points where they are giving. I think this is something we plan to show you this time, and I think we have a coffee break now. Great.
Thank you so much, Jarmo. Does someone has more questions?